Have you ever really thought about what keeps our lights on, especially when something goes wrong with the grid? It's a lot more than just the big power lines we see. Today, we're going to pull back the curtain on one of the most important but least known parts of our entire electrical system. Let's dive in. So what is this invisible hero? Well, it's a really brilliant piece of engineering that's quietly fighting off constant threats to our power supply, 24/7. And by the end of this, you'll know exactly what it is and, more importantly, why our grid absolutely depends on it. All right, so before we can meet our hero, we really need to understand the villains it's up against. You see, the power grid is constantly dealing with these invisible but very, very real threats. Now, these aren't just some boring technical terms. Think about it. Unbalanced loads are kind of like a washing machine with all the wet clothes lumped on one side. It's going to shake violently and put a ton of stress on everything. Ground faults, they're like a massive short circuit, creating a super dangerous path for electricity. And harmonic currents, that's basically electrical noise or pollution that can mess with all our sensitive electronics. If you let these things run wild, you're looking at blackouts and just really poor power quality for everybody. So, how do we fight back against all these invisible dangers? Well, it's time to meet the hero of our story, the tertiary winding. Okay, so what is this thing? Deep inside those massive power transformers you see at substations, it's not just a primary and a secondary winding doing all the work. Engineers add a third, special-purpose coil of wire. And that's it. That's the tertiary winding. It's a really elegant solution designed to solve a very specific and very tricky set of problems. And how it works is actually pretty cool. It's all based on Faraday's law of induction. You see, the main power flowing through the transformer creates this powerful magnetic field in the core. The tertiary winding just sits inside that field, and a voltage gets induced in it, kind of like how a wireless phone charger works. It does its job without ever being directly connected to the main flow of power. To give you some context, let's take a quick look inside a typical power transformer. You've got the iron core, you've got the main windings stepping the voltage up or down, and tucked right in there, alongside them, is our tertiary winding, playing its own unique and vital role among all these other critical parts. So now that we know what it is and where it lives, let's get into the really interesting part, the critical jobs it performs, its superpowers, if you will. Its first, and you could argue its most important job, is to be a stabilizer. During a fault, the system can get seriously unbalanced, creating these rogue currents called zero-sequence currents. Think of them as this chaotic electrical energy with nowhere to go. The tertiary winding provides a safe, closed loop for these currents to flow into, basically trapping and neutralizing them before they can cause a cascade of problems across the system. Second, it's a power cleaner. All of our modern electronics can create this specific kind of electrical noise called third harmonics. This noise distorts the nice, clean sine wave our grid is supposed to have. The tertiary winding acts like a specialized filter, almost like noise-canceling headphones for the grid, trapping these harmonics and letting them circulate harmlessly, which keeps our power supply clean and protects all our sensitive gear. And finally, it has a really practical, clever job. A substation needs its own power, right? For lights, cooling fans, pumps, all that stuff. Well, instead of installing a whole separate transformer just for that, engineers can just tap into the tertiary winding. It is super efficient, and it saves a ton of space and money. But, a hero isn't just born overnight. Before a transformer with one of these windings can ever be put into service to protect the grid, it has to go through an incredibly rigorous series of tests to prove it's up to the job. And this quote really gets to the core of the whole power engineering mindset. When you're talking about our critical infrastructure, you just can't hope for the best. Every single component's reliability has to be proven. It has to be verified through meticulous, painstaking testing. This verification happens at two really important stages. First, there's the factory acceptance test, or FAT. That's done before the transformer even leaves the manufacturer to make sure it was built perfectly. Then, after it's been shipped and installed, it goes through a Site Acceptance Test, or SAT, to make 100% sure nothing got damaged along the way and that it's ready to be safely energized. And the level of detail in these tests is just incredible. During both FAT and SAT, they're checking things like winding resistance to make sure all the copper coils are perfectly intact. They run a turns ratio test to confirm it's going to produce the exact right voltages. These checks guarantee that every single part, including our hero, the tertiary winding, is working exactly as it was designed to. So what's the payoff for all this painstaking work?
It's confidence. It's the absolute guarantee that this critical piece of equipment is ready to be connected to the grid and do its job reliably, not just for years, but for decades to come.
Okay, so let's boil it all down. What's the work of our unsung hero? Number one, it stabilizes the grid by handling those dangerous fault currents. Number two, it cleans our power by filtering out electrical noise. And number three, it supports the substation itself with auxiliary power. Stabilize, clean, and support. Simple as that.
You know, the tertiary winding is just such a perfect example of the incredible, complex engineering that's hidden just out of sight, working flawlessly to make our modern world possible. It really just leaves you with a final thought. What other invisible marvels are out there, quietly and reliably powering our world every single day?